Last day at Staten Island. Yesterday it was literally t-shirt weather. This morning people wake up and they don't believe that there's like half a foot of snow on the ground and it's like blizzard, whiteout conditions. So we're not sure how many calls we're going to get today, since obviously a lot of people are canceling, but it's still we're going to drive around, make some video, maybe pull some people out of ditches. People don't have winter tires around here. Keith says that he's already seen like 3 accidents, fender benders, so I bet the body shops are going to be pretty pleased with this storm. So let's brush off the XL7. You can see the wind was going this way, but yeah, should be fun. Woo! Good thing most people want to stay home in this. That means we can have some fun on the roads. Hey everyone, I hope you guys are enjoying the Staten Island Express series of case studies. I know I am. On this next one, it is a 2006 Chevy Trailblazer. 6-cylinder, 4.2. That was setting a very intermittent code having to do with the throttle position system. So, we recorded the case study, the footage on Staten Island, but Keith wanted me to give you guys some more background info on this vehicle and some code setting criteria, so you kind of have an idea of where we're going with this, because he's already looked at this car at least 3 times, and the problem is so intermittent that every time it came to the shop and he looked at it, you couldn't make it act up. But in this time we nailed it. Again, most of the credit goes to him. I was just the scope guy, but nevertheless, it was really cool to work with Keith and figure out this problem child. So anyways, let's go to ALLDATA and I'll show you what this code is all about and how, what the flowchart says. Alright, so we are on our favorite ALLDATA 2006 Chevy Trailblazer 6-cylinder 4.2, and the code that was being set is a P060E. And the definition for that one is control module throttle position system performance. So that seems like a very generic code. It doesn't say, some sensors wrong or there's a correlation problem. It just says system performance. So let's see what the flowchart suggests that we do in this case. So is the P060E set? Let's see. Yes, go to step 4. Inspect all the APP and TP sensor circuits for short to ground, opens, short to voltage, poor terminal tension, etc. Did you find and correct the condition? So let's say no. There's nothing wrong with our TPS or APP sensors or wiring. So then we go to 8. Test all voltage and ground inputs to the ECM for an open circuit high resistance. Refer to circuit testing and wiring repairs. Did you find and correct the condition? Again, no. Replace the PCM. That's it. That's the end of the flow chart. The history of the vehicle is this one shop, they bought it, I think, at an auction. So, red flag right there. And then I think it had a check engine light on with this, with this code, but it ran fine. They reset it. I don't know exactly what they did or the chronological order, but I know that they sold it to one of their customers. They drove it around for like a month. Then this code popped back up, so they brought it in. Obviously, it's still under their warranty, and they're like, well, we don't know why this code is setting. So again, if it's that intermittent, and they did call Keith to look at this truck, and like I said, he's looked at it at least 3 times, I think, within a span of a few months because the problem is so intermittent. And they just started to replace parts because there's no other option really if you don't see a problem happening right there. So the parts that they replaced, I mean, your typical throttle body, accelerator pedal position sensor, the connectors, I think they checked pin tension. They replaced the pigtails at the throttle body, rewired. They replaced the entire harness from the throttle body to the PCM. It has a new PCM programmed in, and now, the problem was still intermittent, but now it's getting worse and worse, and the shop owner said he can recreate it in the shop by, starting it up. He said it happened more when it was cold. Raise the idle, it's still in park, and then boom, it goes into reduced power mode, sets this code. So in this case, we actually have a window of opportunity to catch this vehicle in the act. So we have to be smart about this, set up our scope. We have to look at our signals for the throttle position, the accelerator pedal position, anything else we can think of, and go from there. So we're on the same page. Hope you guys enjoy the case study. Last day at Staten Island, we're working in the snow blizzard. It's a 2006 Chevy Trailblazer with a very intermittent code that sends it into reduced power mode. It is a P060E, and the shop owner here says he can make it happen for us. So all we can do is set up our lab scope, 4-channel pico. We are at the PCM. We have both accelerator pedal signals, so APP 1 and 2, and then TPS 1 and 2. And we also have scan data. So whenever this code sets, hopefully we'll see a glitch and catch it in the act. So all we can do now is let him do his magic.
All we gotta do is pray.
Pray, yeah. All right. Some dropouts on APP 2 and TPS 1. APP 2, TPS 1. Watch this channel. They are reflected. TPS 1 and 2.
Right. And it's actually happening in pro sport. See right there? Yeah. The little jumps again.
Okay, and then eventually you'll see on the stand data.
Right. There it is happening multiple times right there. Let's see it.
Wow. Yeah.
Now it did it? Okay. So it went to reduced power.
Reduced power. Alright, so now the game plan, we're going to look at... Keith is camera shy. We know that. Keith is happy sitting in a comfy chair and yep. He's like the coach. So anyways, on the scan data, we see that TP1 and APP2 look really crappy. TPS2 and APP1, not so bad. But on the scope, we see that all the signals are becoming noisy when the scan data starts showing those dropouts. So like right there, that was a noisy event, and you can see all the signals are kind of, not happy. So game plan is we want to see where this noise is coming from. So on the wiring diagram, just look at, the sensors here. So we're worried about, let's say, APP2. See, that's a signal wire. Why are we seeing all this noise right here? Why is the computer showing dropouts on there? So basically we want to focus on one sensor, just pick one. We're going to pick TPS1 since that was just as bad as APP2 right here. And we have 5 volt low reference and TP sensor 1 signal. So what we're going to move the scope leads to is just focus on one sensor. We're going to monitor the signal, 5 volt reference from the computer, and a low reference at the computer. And we'll run it again, and hopefully it'll do its glitch, and we'll see on scan data and the scope, and hopefully make a correlation. This is our 5 volt reference on TP1. Look at all that noise. And we're having dropouts again on TPS1. Now it's smooth. See, it's smooth? What happens there? Why does it get noisy? That's what happened? Plug back in. How did you know I do that? Because it's rhythmic. You a moment? You see something here? See if you can put it in the tune. It's cooling fan, right? RPM, that got smoother. Changing cooling fan. What? That's what Alright, so at idle right now, right? We're not commanding the fan to go at any higher speed. Alright, here's what we can do. We can command, while this car is running right now, we can command this fan on through the scanner. Let's command it to go out to up to a higher RPM. And see if we get that change up there on that 5 volt reference. Okay, so bidirectional controls, right?
See, these have a position sensor also.
We got output controls.
Yep.
And electroviscous fan.
Yep.
Maintain 1,500 RPM.
So about,
Okay, we're going to hold it in that range, right? And then continue. What do we want to monitor? Doesn't matter?
Was that? No, you just leave it just the way it is right now. We're just going to turn it on and just give it some...
Coolant temperature too high.
Coolant temperature too high. Oh boy. Alright, so it's already going to have to take control of the fan. It thinks it needs to control the fan, not us.
Oh. We gotta let it cool a little bit.
Yeah, we would have to let it cool
what's the temperature right now?
Well,
cool at 177.
Do this time, right? So right now, the way it is, being that it doesn't think it needs the fan, we're gonna have them put the AC on.
Okay. It's still pretty good on the scope.
Compressor activate.
1 So the fan right now, can we see the fan command? So let's watch the fan command.
Raise it up to 2500 again. See if we can get our noise coming back in there as the fan comes on. There it is. A little bit.
Let's see, do we have a fan command? Cooling fan command, nice.
Yeah, so right now it's commanding 0%. Commanding 0. Let's see. If I wiggle this.
Shouldn't the cooling fan, like if we turn the AC on, shouldn't it command the fan on?
Yeah, but you know what, the cooling temperature may not be getting enough AC pressure. Actually built up, we don't know if those are in the system.
Okay, there we go, we got like 6%, 13, 17. So when it actually shifts,
the control, noise.
once it correlates, when it commands it on, you can hear it. There's the noise.
15%. When it jumps up to about 15, let's see if it does it one more time. I think it's going to be at 15%. Turn it on now. Here it comes. And we're on now. There's a couple of So does the engine feel like changing a little bit as it goes? It's more low. That's the pressure going on. So is it just the speed of the fan? And it's feeding back from the speed sensor here. So let's take
the speed sensor on the fan.
Since we had our let's take our APP sensor. Okay. Let's go back in here and let's look at the what we
or we can take the reference ground.
Oh yeah, reference ground too, because reference ground seems to be pretty solid.
Yeah. Alright, so there's the trouble code just for reference. We're going to clear it out. Clear codes. Yep. Okay, great. Now, since we're suspecting that this cooling fan has some kind of feedback messing up our 5-volt reference, making it noisy, we're probing 2 pins on this cooling fan, and they are the cooling fan speed signal. That's the let's see, the yellow channel, and then the 5-volt reference. That'll be our red channel. So we'll go back to the scope. Okay, so blue is our 5-volt reference for TPS1. Red is our 5-volt reference for at the cooling fan. Green is our signal, TPS1 signal. And then finally yellow is the speed signal from this cooling fan. So we're going to run it and look at these traces. Keith, it's not going to like you, it's not going to act up. You know I'm right. We need the boss. Okay, turn the key off for a sec. Yeah, key off. Cool. So we're at 0 there, and our relay should shut off soon. There we go. And we're at 0s across the board. Obviously we lost comm, so alright. Alright, so we're gonna fire up the truck. Got our 4 channels. Keys on right now. Stop. Yep. So the top 2 are the 5-volt references, TPS1 5-volt, cooling fan 5-volt, then TPS signal and cooling fan speed. There it is. Alright, so here is the money shot on the scope. Right there is where Keith pulled this connector off of the fan assembly, and obviously we lost the speed signal, but look at the 5-volt references. It was completely clean through that whole section. And you know, before we had noise and after he plugged it in, the noise came back on the 5-volt references. Now if we zoom in, let's zoom in right here. This noise is almost like little square waves. That's pretty amazing. And look at our speed signal. I think this right here shows us that the speed sensor in the fan is definitely going wonky, and that is actually causing, look at that, that is causing our feedback into our 5-volt reference. It's almost like pulling it down to ground. See, check this out, Keith. Those little square waves, they correspond to a glitch in the speed signal. Yep. It's almost like pulling the 5-volt reference down. Yep. When it messes up. And we can see that it's very repeatable. That's fantastic.
See, who says white boys don't have rhythm? I saw rhythm.
But see right here, where the speed signal is good, our 5-volt reference is clean. When the speed signal starts glitching, right, that's when we get that noise. That's fantastic. I mean, you won't find that in a flow chart, that's for sure. I mean, what went through Keith's mind when he decided to unplug the cooling fan? I don't know. But that's brilliant. So we'll end it at that. Appreciate you guys watching. And I think this will be the last Staten Island episode, unless we find some more work today, which might happen. But all right, thanks for watching. Bye. So Keith, explain what went through your mind when you decided to unplug that cooling fan.
There I was sitting there enjoying my coffee.
Yeah.
And the whole time that started happening, the first thought that I had was we had taken off a small piece of tape off of the harness that went down into the ECM.
Yep.
And it was just sitting right here, half stuck on and half off. And I noticed that during that time that it was actually happening, I'm saying to myself, what is happening that's so rhythmic that it could possibly go in that way? And I'm just looking at this one little piece of tape flapping in the breeze back and forth, and I'm saying, the fan has a speed sensor, and that's what led me to say, well, let's try that, because I know it has a 5-volt reference. Perhaps it shares the same 5-volt reference in the ECM as what these other ones are using.
Sure.
You know, they have one 5-volt regulator, and that's
so it was pulling that common 5-volt reference.
Right. It's pulling it down in the ECM itself, and of course, you know, you don't get the internals of the ECM to tell us, you know, which 5-volt regulator is which.
Right.
That's just kind of what led me there.
That's so again.
That and lots of coffee.
Dunkin' Donuts.